for the introduction, and thank you for having me this morning, well, this afternoon over there, I guess. Do you see my screen? Yes? Okay. So I will switch off the camera. I think this will be easier. So what I would like to talk about today is work that I have been doing with colleagues of mine from various institutes in Europe over the last couple of years. So I would like to acknowledge my colleagues here, Katerina Bolan, Stefan Dietze, Pavlos Fafalios, and Andon Chekmedjiev from GESIS, which is a social science and computational social science institute in Germany, FORTH, which is a science institute in Crete, in Greece, and IMT in France. So yeah, as mentioned, I'm associate professor at the University of Montpellier, and I would like to talk about our work on constructing a knowledge graph of claims, of controversial claims, or let me be more specific. What I will be talking about is in particular claims that have been fact-checked, so meaning that have been reviewed by some kind of a fact-checking organization. And I would like to describe some initial work on applying this knowledge graph for the task of computational fact-checking. So first of all, let's have a look at how the web has been evolving in recent years. Historically, we have what we know as a web of documents, where web pages are connected between each other, and where we can access, thanks to search engines, to a very rich set of resources, such as documents, videos, or images. For example, by using keywords, keyword-based search, like typing a couple of keywords, for example, Brexit, we will be able to access to results in the form of images or video or text documents. By the advent of knowledge graphs, what we have seen is that there is this tendency of transforming, so to speak, the web into a huge base of knowledge, where we could actually, one of the applications of knowledge graphs, of course, is that they would enable obtaining precise answers to particular questions. For example, if you would like to know when precisely the Brexit referendum took place, we would be able to achieve, to obtain a particular answer, which is the date where this event happened, right? So the 23rd of June, 2016. So how about claims? So what I mean by claims here are statements, for example, that have been uttered by political figures or any kind of persons of influence. And our observation is that there is an abundance of data of this type. So what we call here online discourse data, including claims, but also stances or documents which come to support particular point of view or to refute this point of view. Various controversial topics, different sources and contexts coming with them, right? So our observation is that there is an abundance of this kind of data on the web nowadays, but there is little means that are provided to search and retrieve this kind of data. And in particular, one of the reasons for that is that knowledge graphs, as we know, are mainly and mostly focused on facts. So factual assertions that can be represented by triples. I guess the previous talk referred to these notions quite a bit. But they contain little information about online discourse data of the kind that I have just described. So we observe that there is a need of shared understanding and structured knowledge about online discourse, meaning the claims, the viewpoints, also their truth values, the truth values of these claims, sources, topics, all kinds of contextual information that one could imagine that would come together with claims. So ideally, one would imagine an application in which we would like to retrieve, for example, as I have given here this little example, pro-Brexit claims of right-wing politicians, right? So this data is available somewhere on the web, on various sources, for example, on various news media outlets or fact-checking portals. But retrieving automatically this kind of data over different periods of time, for example, appears to be difficult nowadays. While there is a bunch of interesting applications in various domains, including social sciences, computational journalism, and others. So in this talk, I will first start by explaining or introducing our idea of how to conceptualize, ontologically speaking, knowledge about claims as we understand them here being different as compared to facts. Then I will talk about claims KG. So this is the actual artifact which has come out of this work so far, which is a knowledge graph of fact-checked claims, together with some use cases, which I will describe in a little bit more detail. And finally, I will close this talk by talking about some things that we could do with this knowledge graph, in particular, our initial work on learning vector representations, precisely embeddings, from the knowledge graph, and some applications of these embeddings, of course. So first of all, let's start by this very simple question. So we're talking about claims. So what is that we call a claim? The fact is that there is little agreement about the definition of this more or less simple notion, at least intuitively. So if you look at the Oxford English Dictionary, you will find a definition which goes like, it's a statement or assertion that something is the case, typically without providing evidence or proof. There has been a huge effort from journalists and fact checkers to analyze claims and review statements of politicians online, summarized in different fact checking portals. Well, there usually a claim is defined as a statement that is supported by a group of people or organizations that appear newsworthy, so worthy of being checked for its veracity. In the emerging field of argumentation mining, we can observe yet another different definition, or even several definitions which might be conflicting with one another. If we go to the field of question answering, we see that the claim is defined yet differently. In databases, we will find a different definition. So I can go on for quite a long time and fill this slide with various definitions that we will not be able to read. So our motivation here was to say, yeah, probably it will facilitate our work if we can come up with a definition that is universal and accepted. So the first motivation of this work is, or to model claims would be, or to illustrate this motivation, I would like to give you some examples. So in the first place, if you look at these two claims on the top, Mitt Romney says that Barack Obama could have gotten crippling sanctions against Iran. He did not. And the other one going like, Paul Ryan says the Obama administration watered down sanctions against Iran. So are these two claims the same? Well, to a certain extent, they convey the same meaning, but they have been said by different people at different occasions. So probably the intention behind these two are not exactly the same. So if we look at these two coming afterwards, climate change is a hoax invented by the Chinese, says Donald Trump. Climate change is a hoax invented by the Chinese, says Barack Obama. We would imagine that those two really don't mean the same thing. Probably one of these is said with a note of irony, while the other one is meant explicitly. We have other examples, like if you look at the example at the bottom, Colin Kaepernick says that Winston Churchill said that a lie gets halfway around the world before the truth has a chance to get its pants on. So we have here is a claim which is nested within another claim, and the claim is true, but the claim within the claim is false because Winston Churchill actually never said that. So these are examples which come to motivate the need and the complexity of this task of modeling claims as part of online discourse. we see then that there is a, beyond this complexity, there is a bunch of, or a variety of intentional or unintended meanings that a claim carries. And often a subtle change in the wordings or the way we phrase a particular claim, or a subtle change in a context, can have a significant effect on the validity of the claim. So if we particularly talk about the veracity, meaning truth values, we can observe that modifying very slightly the context or the textual content of the claim could impact its meaning. And I would start here, or hint already to our observation that what appears to be crucial is the intended meaning behind a claim, and not so much its veracity. But I will come back to this a little bit later. So we see that the used terminology and the underlying conceptual understandings of claims are strongly diverging across the different communities. And therefore, there is a need of a definition or clear definitions and some kind of structured knowledge about online discourse data, and in particular about claims, about their contexts, the different parts that constitute them. And hopefully this will enable some kind of machine interpretation and improve the discoverability, retrieval, and reuse of these rich resources. So I will start now by presenting the way we see how a claim can be decomposed and structured and represented. So what we see here is that in our understanding, we have three different components or three main components of a claim. In the center is what we call a claim utterance. So a claim utterance is basically the surface form or a textual content of a claim, particularly the precise chain of words which form linguistically the claim. On the right, we will have a component which we call claim context, and I will describe a little bit more in detail what we mean by that. And on the left, we will have the proposition or the meaning of the claim. So these will be our three main components. So let us have a look at the proposition in the first place. What do we mean by a proposition? Is the meaning or of one or more semantically equivalent claim utterances. So what we see here is that the claim proposition can be seen as a identifier or a pointer that groups together a set of equivalent, semantically equivalent utterances. So we can have utterances that are phrased differently, that have different textual content, different surface forms, but they mean the same thing. And this is where the proposition comes in. So what we attach to the proposition class would be several components. So in the first place, we have some kind of a representation. So this representation can be a logical representation, or it can be also a textual representation. So one may want to choose one particular service form as being the head form of the proposition. So the identifier that I was referring to. What we have here also is a review. What is a review? Well, as we are interested in claims that, well, some of them at least have been reviewed by fact-checking organizations, usually these claims come with an article, which we call a review, that explains the process, the journalistic process behind coming up with a decision whether the claim is true or false. And so we assign a class which would group these kind of reviews to the proposition here. Then we have something that we call attitude, which roughly speaking would be equivalent to a stance or to a point, to a viewpoint that we also associate to the proposition. And an attitude or a stance is associated to a topic, usually some kind of controversial topic, as the one that I had in my example, which was the topic of Brexit. If you take COVID-19, I think we would all agree that also the degree of controversy is sufficient so that it can be considered as a topic of interest in this situation. So then what we have in the utterance would be a, so in the first place, we have a representation of the utterance, which is a linguistic representation. What we are interested is to extract a set of annotations from the linguistic representation. So annotating linguistical different entities, for example, but also linguistic cues within the textual content that can be important features for particular machine learning tasks or NLP tasks. And then what we have under the utterance class would be also the source. So where this utterance has been sourced from. And finally, the context component of the claim is a set of classes and properties which aim to answer these four WH questions. So who, where, when, and why. So this is where we would have, for example, the date, location, and the event where the claim was uttered, and its author, for example. So what you have here, I suppose it's a little bit difficult to read, but it's not also essential that we are able to read all the different components. So what we have here is an example of an instantiation of our model. So roughly speaking, what you have in this part here, I guess you'll see my marker, is an example of instantiation of the proposition class. What you see here in the middle are two different utterances. So as I mentioned, we can have two utterances that are assigned or associated to the same proposition because they are semantically equivalent. And what you have here are the associated contexts to each of the two utterances. So basically, what we can see is that the combination of a context and an utterance could imply a particular proposition, according to our model at least. And just for those of you who are into semantic web technologies, of course, we have also provided an implementation of this model by relying on existing ontologies and different schema, in particular schema.org and the claim review class of schema.org. For modeling stances, we have relied on the Marl ontology. Again, this is just an example or sketch of an implementation. Many different implementations in RDF could be possible. So I'm coming to the second part of my talk, where we would see how in practice we can use this model or a version of this model in order to, well, populate it by extracting real-world knowledge from the web. And in particular, as I mentioned, I will explain here the claims KG knowledge graph, which is a knowledge graph of fact-checked claims. So we have seen that investigations into falsehoods, misinformation, and how those falsehoods spread on the web have been gaining popularity over the past years. Multiple questions have been motivating research in these areas in different fields. For example, how do false claims spread on social nets? We have seen in a recent paper published in Science that falsehoods spread way faster than true statements over the social networks. Other questions that have been asked, or answers to which we have been trying to find, were, well, how to assess the veracity of claim. A very important and active domain of computational fact-checking has been trying to look into this question. Or, well, what is the stance of the claim? How can we automatically detect the viewpoint expressed by a claim, or find web documents which are relevant to the stances, different stances associated to a particular claim or a point of view? Well, for most of these studies, there is a clear need for ground truth data, which is constituted by claims and their labels, meaning their truth values. For example, for fact-checking, right? So we would need some kind of ground truth data where we can use to train machine learning algorithms to automatically detect whether a claim is true or false. In other applications, well, there are specific information needs, for example, by social scientists or fact checkers or journalists, needs to retrieve and to retrieve particular kinds of information. For example, wanting to know what are the all false claims uttered by, for example, the former U.S. president in 2017 that also mentioned the FBI. Or else find the top 5 politicians per month that are involved in false claims. Right, so these are complex queries which one could potentially obtain this information by looking up manually a number of different decentralized sources, for example, fact-checking portals or various encyclopedic knowledge bases. Of course, the need here is to enable an enhanced retrieval of claim-related information in the sense of centralizing somehow these distributed sources so that one could access from one could access this information and obtain this currently distributed data by a single query. So there has been some effort in this direction recently. Certain resources have been published in various research projects. For example, we have data that has been extracted from web resources, particularly fact-checking claims, or data that has been crowdsourced and manually annotated. What those data sets have in common is that they're often limited in size, they're static and not regenerable. There is a certain lack of metadata and context, and yet again, there is no shared schema that these different data resources obey. So what we present here is claims KG. As I mentioned, this is a knowledge graph of fact-check claims. Well, in the first place, it is a data set with openly available claims with associated metadata. It's dynamic, meaning that we are maintaining and updating this resource regularly. But it comes with a model, a schema that describes knowledge about fact-check claims, which is a subset of the schema that I have just shown, or at least inspired by the schema that I have just shown in the first part of my talk. It also comes with a bunch of tools for its construction. So an open source pipeline that allows for harvesting data from different fact-checking sites and lifting it according to our model. And it also comes with a bunch of web applications that allow to search our data and explore it, for example, to answer information needs as the ones that I have mentioned in the couple of slides just a minute ago. So to make it simple, in this part of my talk, I will refer to a claim. When I refer to a claim, I would mean a statement that is reviewed by a fact-checking organization. So as I mentioned, the model that we have used to build the claims KG subset, or a simplified version of the model that I have explained in the first part of my talk. So I will just skip this this part, maybe just to illustrate a little bit what we have here. Would be a claim. For example, we will find the textual content of the claim. Donald Trump says blah, blah, blah. The date that it was published, some references to external resources, well, the author, which is linked to other sources like DBpedia, for example. And then we will have information about the fact-checking website, which has reviewed the particular claim. For example, yeah, we have the URL of the fact-checking organization, its name, well, the date when it was published, in the language in which it was published, and so on. And then we have information related to the rating, so the truth value of the claim. So what I would like to just open a small parenthesis here is to emphasize the fact that, well, various fact-checking organizations have different different means to represent their truth values. Usually they're somehow constructed for their own purposes. If you take the example of PolitiFact, you have something like 6 or 7 different truth values. For example, true, mostly true, false. They use even the word pants on fire to indicate that something is outragingly false, for example, right? And so in order to come up with some kind of a uniform schema of ratings, we have only used 4 very basic truth values for our model, which are true, false, mixture, which is anything which is on a scale between true and false, and other, which is anything which is neither true nor false nor either of these two. So we have, for example, sometimes ratings such as under review, meaning that the claim is not yet has not yet been evaluated by or assessed by the fact-checking organization. And those the mappings from the original ratings to those 4 simple truth values has been done manually for each of the portals that we have been harvesting information from. So I will very briefly say a couple of words about how we extract our data. Yeah, so in the first place, we have a number of portals where we crawl data from. So currently we have something like 8 or 9 portals that we are using. Major update of our data is coming in the following days, where we'll be doubling the number of sources that are currently included. So what I would like to mention here is that most of these sources are currently in English, although they come from different countries. Notably, if you have data coming from an US portal and data coming from a UK portal, usually we'll have claims that are very little intersection because they're dealing with domestic politics predominantly. So our aim is, of course, to enrich the data by including sources of different languages, which will increase the coverage and the heterogeneity of the diversity, of the data that we represent. Then we have a component of extracting claims, where according to the information which is available in which resource, we try to fill in the different classes and so to instantiate, so to speak, our model. So we collect the text of the claim, its truth value, the text of the claim review, so the article which comes with the reviewed claim. We extract the references that are included in this text, as well as the entities from the claim and from the text of its review. The authors, the dates, the titles, and so on. There are sometimes keywords that come with the data that we also store. And sometimes they act also like topics, such as healthcare or abortion, for example. And wherever possible, of course, we link all this data to other resources, such as DBpedia, in order to anchor our data to the web of data. So yeah, as I mentioned, we extract entities and we annotate those, the text with the URLs coming from DBpedia, and then we lift this data by populating our model. So I would like to point your attention to is that we, in addition to, of course, Sparkle endpoint, where we can access our data, we provide also some user-friendly applications that are accessible and easily accessible to everyone. For example, the Claims KG Explorer or the Claims KG Statistical Observatory, which allow to, for example, explore claims by politicians, filtering by keywords, by entities, by time periods, topics, and so on. These are applications that also allow us to learn more about the statistics. For example, when was the peak of false claims last year and on what topic? This can also allow us to discover different trends. For example, how have falsehoods about immigration been spreading over the past 7 years, say? And finally, as I mentioned, of course, extract label data in order to train fact-checking tools. So we can very easily make an export by using the web applications and the interfaces we have. of data, for example, just taking the truth classes and the false classes and extract all metadata related to that, and then try to do some machine learning on this basis. So these are just screenshots from some of these applications that can give you an idea. But of course, you have all the links. I guess the slides will also be made available so that you can have a look and explore it on your own. Some statistics currently, we have about more than 30,000 claims in our knowledge graph. What I would like to point your attention to here is that, well, we can see that our data is clearly unbalanced, meaning that there are way more false claims than true ones. Well, this is probably also something that comes quite naturally from the properties of the sources that we are harvesting data from, meaning that fact-checking organizations are often interested in controversial claims, which in many cases turn out to be false. Of course, and here I'm opening yet another parenthesis, but I think this is an important point to mention. There is a significant bias coming from data which has been harvested from fact-checking portals. And I don't mean to spread any kind of controversy here or put under question the work that has been done by journalists and fact-checkers, but these are journalistic organizations which have their own editorial lines, right? And the very choice of what claims to review is already a part of this editorial direction, right? And this is also part of the biases which would come together with this kind of data. And I think it's a worthwhile question, just because many people nowadays who would do automatic fact-checking would use such kind of data. We have seen that some of them use our data, for example, from Claims.kg. So this is a straightforward idea to look into this kind of data in order to perform fact-checking. But one should keep in mind that there is a bunch of biases coming with claims that have been harvested from established fact-checking portals. So yeah, right. So to close, we have seen that with Claims.kg nowadays, what we can do is advanced entity-centric search and exploration of information. We can now obtain easily answers to very complex queries, such as, for example, well, what are the top 5 persons mentioned in false claims together with the word abortion, right? So we have already seen a couple of use cases from our colleagues in the social sciences, which use Claims.kg as a support to their research. For example, into agenda setting studies on the influences of mass media on the public opinion and attention, or studying the evolution of political discourse about a particular topic over a particular time period. And finally, as I mentioned, of course, this resource provides balanced training data sets, balanced, of course, under the condition that one takes care to balance the data. For doing AI research. And just very briefly, I will finish my talk by presenting a couple of or our initial work on learning embeddings from the knowledge graph. So just very briefly, what we aim here is to generalize well-known word embeddings or distributed representations of words in a vector space that are based on neural models in most of the cases, which use the context of a word within a huge corpora to predict the words in its neighborhood, or inversely, if we have the neighborhood to predict the word. So this is how the representations are optimized. And graph embeddings generalize on this idea. So what we have done here is that we have taken Claims.kg with all the metadata that it contains, meaning the claim text, the claims contextual information like the dates of publication, authors, keywords, and so on, the claim review, and so on. And we have constructed different corpora out of it. So in the first place, we have just using the claim text or what has been said. Then we have the Claims.kg knowledge base together with its contextual information, where we have who, when, where, about, and what was said. And finally, we have the third version where we have knowledge also brought in from DBpedia. Basically, what we have done is for each entity, we have extracted a limited amount of additional knowledge from DBpedia, which comes into filling particular contextual gaps. For example, what we could retrieve in this case additionally as information that we don't have initially in claims KG would be, in some cases, for example, the political partisanship of some figures, which in particular cases for predicting the truth values of claims could be a useful feature. And then based on these three different corpora, or three different data sets, we have learned vector representations, and we have used them, applied them in order to perform binary classification for the task of predicting the truth values of the claims. So again, this is work which comes to illustrate how embeddings can be learned and what we can do with them. We had three hypotheses that we had formulated here. The first place is that the text or graph embeddings learned from claims KG, both the base version and contextually enriched version of the data allow for good prediction properties of a large number of classifiers for the fact-checking task. So fact-checking here again is seen as a binary classification problem. The second hypothesis was that the graph embeddings would outperform text embeddings in this task. So basically the idea here is that to say that more than what is being said, what matters here is the context in which it has been said, if we want to predict truth value of a claim. And finally, quite straightforward hypothesis, the richer the contextual graph of the underlying representation, the higher the performance of this of the classifiers would be. So I will summarize our results. What we saw that is that, so again, we have trained text embeddings only, and then graph embeddings, and we have tried to compare those. So what we have seen is that in all cases, learned embeddings allow to achieve good classification on our data. The embeddings learned from text obtain slightly better performance than those learned on graphs. So this comes to contradict our second hypothesis. What we also have seen is that the embeddings learned from the extended version of the graph, meaning where we had also knowledge from DBpedia, which comes to enrich our initial data, achieve better performance than those learned from the base graph only, which supports our third hypothesis. And we also observe that predicting false claims in the general case is less error prone. So we're better in predicting the false labels than the true ones. So I would just like to make one comment here before I close regarding the second observation. So again, we have observed that text embeddings seem to perform just as good or even slightly better than graph embeddings. Our initial hypothesis was that actually context, which comes from the knowledge graph, would help us improve the baseline text embeddings classification. That was not the case, because what we have done here is just transfer already learned models into our data. So what we have here is an intuitively, so say, insight is that, well, basically, the models that we have tried to fit into our data do not capture the topology of our graph. So we will need to change the optimization functions behind them in order to see if this hypothesis really holds. So basically, what we can, the bottom line here would be that the existing models transfer poorly on our data. So I will close my talk here by saying that, yeah, we're intensively working on many different topics related to what I have been discussing with you today. And one that I would like to underline here is that I think I mentioned already in the beginning, what we are currently really interested into is the topic of intent discovery, meaning that, well, our main observation after a couple of months and maybe even years of looking into those questions is that what whether a claim is true or false is not that important at the end of the day. What really seems to matter is what is the intention behind a particular claim. So the very question of why a particular person utters a particular claim in a particular occasion. But this appears to be a more complex problem. So I thank you for your attention, and I'd be happy to take your questions.
Thank you, sir. Sir, we already have 2 questions in our chat box. I would read out. We have one from Gopalji. He is asking us, political claims can be sarcastic in nature. How this model handles it?
Political claims sarcastic in nature. Yeah, of course. I mean, so as I let me go back to our model. So the simplified version of our model, as you see here, we have the utterance and the proposition and the context. So sarcasm is expressed linguistically, right? So, but it's captured in the meaning. So where the difference would come is that if we have a sarcasm which comes to modify a particular utterance, then in our model or in the instantiation, those two claims, those two utterances, one which is straightforward and another one which is sarcastic, would be attached different propositions. And I actually had an example. So this one, if you remember from the beginning of my talk, it's exactly the same utterance. One of them is being said sarcastically. One can imagine that Obama, when uttering this sentence, has been mocking Donald Trump about his statement related to climate change. So yeah, in our model, ideally, the second claim and the first claim would not be assigned the same proposition. So this is why it appeared to us very important to distinguish between an utterance and a proposition. And the context here plays a very important role, because what could hint that one of these two utterances being said sarcastically is the author in our case, and knowing particularly the context of how this claim has been uttered. How do you recognize sarcasm? That's a different question. So this is where I also mentioned that what we want to have are also annotations related to the linguistic representations. So these annotations can be also purely linguistic cues, where we can also have cues for sarcasm, for example, if this can be recognizable in some form in the natural language expression of a claim, right? So ideally, sarcasm could be also encoded in the information that we would instantiate in our model. I hope that answers your question.
Thank you, sir. We have one more from Susmita. She is asking us, can fact checking be implemented in real